Hello again, I'm Dr. Lennick, and today we're going to continue on with looking at quadratic functions. In this second program, we're going to take a look at graphing a quadratic function. And so what we want to do is look at examples of how to graph a quadratic function. All right, last time we recall we were looking at a quadratic function in the form of f of x is equal to ax squared plus bx plus c. And so now we're going to take a look at applying that definition and to the graphing of a function. And the first thing we want to do when we graph a quadratic function is we want to determine the end behavior. This is what we referred to last time in determining whether the function was opening upward or downward, and that was looking at the coefficient, lead coefficient a. Next, we're going to look at finding the axis of symmetry. So we're going to find the axis of symmetry. It'll be the second step. From there, we're going to find the vertex. Remember that the axis of symmetry is the x-coordinate in your vertex. After we find the vertex, we're going to find the x-intercepts. And once again, we want to note that sometimes these x-intercepts are not real numbers. In other words, we may get a complex solution here when we try to determine the x-intercepts and set our equation equal to 0. So keep that in mind, and occasionally you will have no real x-intercepts. Next, we're going to find the y-intercept. And then finally, we're going to use the y-intercept to find another point, and we're going to use that in conjunction with the axis of symmetry. Okay, so let's go ahead and see how we graph a quadratic function. And so we have the quadratic function, again, in the general form here of f of x is equal to minus x squared plus 6x minus 3. I also want to note here that I've got this written as example 3 because we're continuing on from program 1 in our number of our examples here. Okay, so the first thing is we want to determine the end behavior. And so looking at this, since a is equal to -1 and is less than 0, the parabola will open downward. All right, we remember this from the first program that we can look at the lead coefficient to determine the end behavior, whether the parabola generally opens upward or opens downward. We also want to remember that a can also tell us something about the vertex. In this particular case, since a is less than 0, we know that our vertex will be a maximum. Next, let's find the axis of symmetry. So the axis of symmetry, again, we're going to apply the formula x is equal to minus b all over 2a, and that's part of also finding the vertex. So we'll come in here and we'll say, let's putting our b, which our b is going to be 6, so we get -6. In the denominator, we'll see that we'll get -1 is our a. So we end up with our axis of symmetry being equal to 3. So we have the equation x is equal to 3. We can come up to our graph and we can pencil in this axis of symmetry. We'll just put a dashed line here at x is equal to 3 all the way up and all the way down. And so we know our left and right side of our parabola will be opening about that axis of symmetry. The third step then is to find the vertex. And to find the vertex, we're going to use the x-coordinate, which we just found, which is our axis of symmetry. And so we're going to plug that value into our function. All right, so everywhere we see an x back up here in the function, we're going to plug in the 3. So our notation becomes f of 3 is equal to minus 3 in parentheses squared plus 6 times 3 minus 5. Now that comes out to be equal to -4. One of the things you need to be really careful with is notice that we had a negative in front of the x squared term. All right, so our negative in front of our x squared term. And so notice how I've written that here and how I've applied that. This becomes -9 when I do the math there, and then we'll have plus 18 minus 5, and that will give us our positive 4 for our y-coordinate, our vertex. So our vertex comes out to be the point 3, 4. And again, we can put that point on our graph, and so right there is our point 3, 4. And so we have our vertex. And we also know that the parabola is opening downward, so we know that vertex is going to be a maximum. And so we know here too, as we look at this and talking about our domain, we know our domain for quadratic functions, there's no restriction, so our domain is all the real numbers from negative infinity to positive infinity. And now we also know that our range, since it's going to open downward, that 4 will be the upper value of our range. And again, we're going to put a square bracket there. And our parabola is going to open downward in this fashion. And so since it opens downward, the lower end of this will be negative infinity. In other words, it just keeps on going. There's no, it's unbound in the downward direction. All right, so just from looking at our vertex now, we've got our domain and range. All right, we need to continue on because we've, again, got a very important point here. We've got the nature of what's going on, and so we want to actually get the whole graph. All right, so the next thing we're going to do, again, we've got our vertex of 3, 4 here, so I'm just going to pencil that in again here. All right, so there's our vertex, and now we're going to find the x-intercepts. And so what we're going to do is we're going to use the quadratic formula. In program 1, we reviewed the use of the quadratic formula and how to proceed. And so here what we're going to do is we're going to remember that the quadratic formula is going to be equal to minus b plus or minus the square root of b squared minus 4ac divided by 2a. Now, before we go any further, we got to keep in mind something about using the quadratic formula and finding the x-intercepts here. And that is that what we're doing here in finding the x-intercepts, we're letting y be equal to 0. So our function becomes 0 is equal to minus x squared plus 6x minus 5. Okay, so that's important to recognize that we're setting y equal to 0 here. And so now we can use our quadratic formula effectively. It's important to understand that as we go along, that y is equal to 0 here, finding the x-intercepts. So now we're going to plug in. Again, as we look at this scenario, we see that what happens, our a is equal to -1, our b is equal to 6, and c is equal to -5. All right, so we're going to plug into our quadratic formula, and so we get x is equal to minus 6 plus and minus underneath the square root 6 squared minus 4 times -1 times -5 divided by 2 times -1. Solving this and simplifying underneath the radical, we get 36 minus 20. And out in front we have minus 6 plus and minus the square root of 36 minus 20 underneath the radical, and all that divided by -2. Simplifying, we get -6 plus and minus the square root of 16 divided by 2. Again, the square root of 16, that's a perfect square, so that comes out to be 4. So we get -6 plus and minus 4 divided by -2, which leads us, when we take minus 6 plus 4 divided by -2, we're going to see that that's going to give us a -2 over -2, or x is equal to 1. We take -6 minus 4, that gives us -10 over -2, and so we get x is equal to -5. And so right now what we can do is come up here and say, all right, we've got the point 1, 0 here, and 5, 0. And so, hey, we're starting to get a feel for what the shape of this parabola looks like as we graph it here. So we can start to rough sketch that to the axis here, to the x-axis. And so now what we like to do is say, well, what happens after that? Well, the next step is, we like to figure out what's going on below the x-axis there. And so to do that, we're going to take a look at finding the y-intercept. All right, so our y-intercept here, we're going to let x equal to 0. And so when x is equal to 0, we plug that 0 into the function, and we get y is equal to -5. And so what we have here in this graph is, so far, we have the vertex up here at 3, 4. We've got one x-intercept here at 1, 0. We have another x-intercept here at 5, 0. And now we have a point down here at 0, -5. All right? And so we're starting to get a good picture of what's happening with our graph there. The only trouble is that we have, we have 4 points there, and we'd like to get a fifth point. And so what we're going to do to get that fifth point is we're going to remember that the vertex up here was associated also with our axis of symmetry. And so we're going to remember that our axis of symmetry comes all the way down here at x is equal to 3. And so let's get that drawn in there so we know they're here. So x equal to 3 is our axis of symmetry. And so I'm going to show you a little technique here that we can use to find another point. And this works very well when your y-intercept comes out to be a nice integer value. And so we're going to know this, that as we look at our y-intercept, if we start our axis of symmetry and go over to our y-intercept, we can go over 1, 2, 3 units to the left of our axis of symmetry gives us our y-intercept there. All right? Well, what we're going to do is, since the axis of symmetry, if we go an equal distance in either direction from our axis of symmetry, we should have a point on the graph. And so what we're going to do is we're going to go over 1, 2, 3 units to the right of our axis of symmetry now. And so we'll see here that we have the point 6, -5. And that will also be a point on our graph. In fact, if we plug this in to check it, and because I know everybody's saying, well, let's check that out. So we're going to plug in a 6 into our graph, and so into our function, excuse me, to see if that's actually the point on the graph. So we'll have -6. Again, we're going to square that 6 plus 6 times 6 minus 5. All right, and so this gives us -36 plus 36 minus 5. Well, minus 36 plus 36 cancel each other out and give us 0. So we in fact see that the value of the function when x is equal to 6 is in fact -5. So aha, we found that point. And we found that point fairly quickly and easily. And so again, we have that dot there, so we can now draw out our parabola. Sketch it out. And we'll get this coming down here. Yeah, let's clean up that end a little bit there. All right, so we sketch our parabola out. There we go. And now make sure as you're sketching your parabola in the downward directions that you do put arrows at the end to indicate that your parabola is going in the downward direction. And again, I short-change that side of it here, but we can bring it down a little bit more like that so it looks a little bit more even. Okay, so we've graphed this quadratic function, and notice that we have 5 points on there. And it's usually best in graphing quadratic functions to try to get a minimum of 3 points, really, the vertex and your 2 intercepts if they exist. But that'll give you a good rough sketch of it. But it's better to have 5 points so that you get a little more accurate view of actually where your parabola is. Because if you just have the 2 points, as you go downward, you may push your parabola out too far, or you may push it in too close. And so you want to keep that in mind as you're graphing quadratic functions to try to get a most accurate picture as you possibly can. And once again, you could put this into your TIA3 or TIA4 calculator, or into a program that you might have on your iPad that does sketching, and come up with the look of the parabola. But the key thing is you need to be able to identify accurately the points, and the methods we showed you here will give you the most accurate values of those points. Okay, so this ends our presentation on the graphing of quadratic functions. In part 2, we're going to take a look at the standard form of the quadratic functions, and we'll do a little bit more graphing with that standard form. Here we're using the general form of the quadratic function to do the graphing. In part 3, again, we'll take a look at how do we use the standard form, and we'll do a little more graphing then.